New Forbidden Zone class of black hole discovered. 7 billion years ago, two black holes crashed into each other and merged into one enormous black hole with a mass of 142 suns. All this and more in our video about the new Forbidden Zone class of black hole discovered. Welcome to Trending's Finest, where we give you the hottest updates on the world's most viral news, videos, and stories in the most exciting format. Click that subscribe button and hit the notification bell to not miss a single beat of the world's pulse. Astronomers have discovered the most massive black hole collision ever observed, and also the most distant at 7 billion light years away, meaning it happened when our universe was only half its current age. More intriguingly, the black hole merger originated in two black holes of a size that has never been observed before, according to new research published this week. Find out the details of the discovery, the excitement behind it, and most importantly, what this means for you and me. Stay tuned. The Forbidden Zone Black Hole. 7 billion years ago, two black holes crashed into each other and merged into one enormous black hole with a mass of 142 suns. The collision reverberated throughout space and time, and these ripples, a phenomenon called gravitational waves first predicted by Albert Einstein, traveled 16.5 billion light years through the universe, reaching Earth in May 2019. For 1/10 of a second, the waves stretched the mile-long arms of two enormous physics observatories, the Laser Interferometer Gravitational Wave Observatory, or LIGO, in the US, and its Italian companion observatory, Virgo. The scientists behind these observatories immediately knew they'd detected something unique. Nelson Christensen, a Virgo scientist and a researcher at the French National Center for Scientific Research, described it as much more than a chirp, which is what they typically detect. This is more like something that goes bang, and it's the most massive signal LIGO and Virgo have ever seen. The black hole merger the observatories detected is the most massive and distant they've ever picked up. But more strikingly, it defies the known laws of physics. The scientists' calculations showed that the heavier black hole of the two that crashed was 85 times the mass of the Sun, falling within a range that many physicists thought impossible. This is exactly what I predicted wasn't there, Stan Worsley, an astrophysicist who models the deaths of massive stars, the process that creates black holes, told Business Insider. A big black hole smack dab in the middle of the Forbidden Zone. Described as mind-boggling by computational astrophysicist at Leiden University in the Netherlands, Simon Portugues-Zwart, this excitingly confirms the existence of intermediate mass black holes, objects much more massive than a typical star, but not quite as big as these supermassive black holes that inhabit these centers of galaxies. The event, described in two papers published on September 2nd, was detected on May 21, 2019, and is named GW 190521 after its detection date. It's time to pay up in wine for some. It's a very exciting thing from the perspective of discovery in physics, because this event opens more questions than it provides answers, according to Alan Weinstein, a LIGO scientist and professor of physics at the California Institute of Technology. Black holes form when heavy stars die and collapse. Their gravitational pulls are so strong that not even light can escape. There are two main types of black hole: stellar mass, which are tens of solar masses, and supermassive, which have the mass of millions or even billions of suns. At least there were just these two types before. The 142 solar mass black hole that formed as a result of this 7 billion-year-old collision is the first detected that's between 100 and 1,000 solar masses. This intermediate mass object could reveal a missing link between two types of black holes. It may also help scientists understand where supermassive black holes come from. But the 85 solar mass black hole involved in the collision wasn't supposed to exist at all. Though black hole sizes can range from microscopic to the size of the universe, Worsley said all his models suggest that when it comes to pairs of stars orbiting a shared center of gravity, it'd be very hard to form a black hole with a mass between about 50 and 130 solar masses. Instead, physics models suggest that stars in that mass range should die in a unique type of supernova explosion that annihilates the star, leaving behind no material to collapse into a dense black hole. But you can't argue with Mother Nature, and this discovery seems to show Mother Dear dictating that our big-brain physicists are still quite behind and need to rethink their models. That may also mean paying up on a lost bet against the gravitational wave researchers. Woolsey revealed that because of this discovery, they owe bottles of wine to their peers. Long before Einstein predicted that collisions of massive objects like black holes and neutron stars would produce gravitational waves, but he didn't think anyone would ever detect those ripples in space-time. They seemed too weak to pick up on Earth, amid all the noise and vibrations here. For 100 years, it seemed Einstein was right. But in the late 1990s, LIGO's machines in Washington and Louisiana were built in an attempt to pick up the signals. For the first 13 years, they waited in silence. Finally, in September 2015, LIGO detected its first gravitational waves, signals from the merger of two black holes some 1.3 billion light-years away. The discovery opened a new field of astronomy, and 3 researchers who helped conceive of the experiment earned a Nobel Prize in Physics. Since then, LIGO and Virgo have identified 2 other types of collisions. The observatories register gravitational waves from 2 neutron stars merging for the first time in October 2017. In August 2019, LIGO and Virgo detected what scientists believe was a black hole swallowing a neutron star. All throughout, LIGO and Virgo have provided new insights into the cosmos by sensing gravitational waves. These ripples in the fabric of space-time can reveal events such as the mergers of black holes that would not normally be visible with ordinary telescopes. From the properties of the gravitational waves, such as how they change in pitch, astrophysicists can estimate the sizes and other features of the objects that produced them as they were spiraling into each other. This has revolutionized the study of black holes, providing direct evidence for dozens of these objects, ranging in mass from a few to about 50 times the mass of the Sun. These masses are consistent with black holes that formed in a conventional way when a very large star runs out of fuel to burn and collapses under its own weight. But the conventional theory says that stellar collapse should not produce black holes between 65 and 120 solar masses. That's because towards the end of their lives, stars in a certain range of sizes become so hot in their centers that they start converting photons into pairs of particles and antiparticles, a phenomenon called pair instability. This triggers the explosive fusion of oxygen nuclei, which rips the star apart, completely disintegrating it. In their latest discovery, the LIGO and Virgo detectors sensed only the last 4 ripples produced by the spiraling black holes, with a frequency that rose from 30 to 80 Hz within 1/10 of a second. While relatively smaller black holes continue to chirp up to higher frequencies, very large ones merge earlier and barely enter the lower end of the frequency range to which the detectors are sensitive. In this case, the 2 objects were estimated to weigh around 85 and 66 solar masses. This means that they were in the range of the in-between, or what the physicists call the forbidden zone. Cue Twilight Zone music, people. How did this happen? And more importantly, what does it mean for you and me? Stay tuned for the second half of our video to find out. Explanation behind it. To explain their observations, the LIGO researchers considered a range of possibilities, including that the black holes had been around since the beginning of time. For decades, researchers have conjectured that such primordial black holes could have spontaneously formed in a broad range of sizes shortly after the Big Bang. The main scenario the team contemplated is that the black holes got so large because they were themselves the result of earlier black hole mergers. Black holes resulting from stellar collapse should team inside dense stellar clusters, and in principle they could undergo repeated mergers. But even this scenario is problematic because following a first merger, the resulting black hole should typically get a kick from the gravitational waves and eject itself from the cluster. Only in rare cases would the black hole stay in the area where it could undergo another merger. Successive mergers would be more likely if the black holes inhabited the crowded central region of their galaxy, Domingue says, where gravity is strong enough to prevent recoiling objects from shooting out. It's not known in which galaxy the merger happened, but in roughly the same region of the sky, a team of researchers spotted a quasar, an extremely bright galactic center powered by a supermassive black hole undergoing a flare around a month after GW 19/05213. The flare could have been a shock wave in the quasar's hot gas produced by the recoiling black hole, although many astronomers are cautious to accept that the two phenomena are related. This is the second time this year that the LIGO-Virgo collaboration has waded into a forbidden mass range. In June, they described a merger involving an object of about 2.6 solar masses, typically considered too light to be a black hole, but too massive to be a neutron star. What now? It's hard to sneak a peek into a black hole. Not even light, the fastest known thing in the universe, can escape its gargantuan gravitational pull. Shep Doeleman, senior research fellow at Harvard University and director of the Event Horizon Telescope, EHT, at the Harvard-Smithsonian Center for Astrophysics, puts it simply by saying, "You've got something that's just designed not to give up its secrets." Astrophysicists coined the term black hole in 1967, and there's a reason the elusive beasts have fascinated us in the decades since. Each has a colossally dense center. The one inside M87 galaxy is 6.5 billion times the Sun's mass. That creates immense gravitational pull, sucking up practically everything nearby. Around the center, though, is a visible point of no return, called the event horizon, where gas and debris create a glowing silhouette. One problem? In the vastness of the universe, black holes are tiny. Their density is akin to squeezing a star larger than the Sun into New York City. Making out M87's signature is similar to spotting a quarter on the moon from your backyard. There's no environment in the universe like a black hole. Being able to see such an object gives us a natural laboratory, Doeleman says. We can test long-standing theories about how objects move through space, like Einstein's general relativity, by watching gravity-driven warps and space-time impact how light travels. We can also study how black holes help shape the universe by sucking up matter. In Doeleman's words, nature is providing us with a sandbox. And it looks like our top physicists and astronomers are all too excited to play in this sandbox of nature. What about you? What do you wonder about the greater universe in the grand scheme of things? Tell us in the comments down below so we can talk about it some more. If you want to learn more about the final frontier that beckons from just beyond the horizon, you should check out our other video. The search for dark matter is still on. After Study rules out dark matter destruction as origin of extra radiation in Galaxy Center, where we cover the idea behind dark matter, the motivation behind the search, the observations fueling the search, the theory for the search, and finally, we'll talk about the hunt, including the recent discovery or non-discovery of dark matter in the Milky Way's galactic center. Keep watching. Thank you for watching. This is Trending's Finest. Always the trendiest, always the finest.